Good morning, friends, and welcome back to Heat Transfer. Um, I hope everybody is doing well, and we will get started from where we left off in the last class. If you recall, in the last class, we had just started discussing about internal flows. Okay, and this is part of force convection. Internal flows means that you have a structure and the flow is happening inside it. The most common embodiment or configuration of that is flow through a pipe or a duct or a channel, right? So that is internal flow, and you have studied during your course on fluid mechanics that when you have internal flows, firstly, like external flows, there is something called Reynolds number. Reynolds number, however, for internal flows is defined based on the diameter of the pipe instead of the length of the flow, right? So as a result, unlike external flow like flow over a flat plate, the Reynolds number does not change in the direction of flow. Correct? Reynolds number remains constant right from the inlet of the pipe to the exit of the pipe. Okay. So, what is the implication of that? The implication of that is if a flow, before that, taking a step back, the transition Reynolds number for conversion or for a flow to turn from laminar to turbulent for internal flow is 2000. Some books you may find it to be 2200, 2200, whatever. Okay. So now, since the Reynolds number does not change along the flow length, since the Reynolds number doesn't change along the flow is laminar or turbulent throughout. Unlike flow over a flat plate, which under normal course of action will start off as laminar, and as the Reynolds number keeps increasing along the flow direction, at some point it is going to exceed the threshold value and become turbulent. Okay, so I'm repeating this probably a few times because this is an important concept that you must understand. Now the question is, why is it that we define Reynolds number in terms of the diameter, or take the diameter as the length scale in Reynolds number instead of the flow length? That is because what we were discussing in the last class is over here in a flow over a flat plate, the momentum boundary layer keeps increasing, keeps growing and increasing. Whereas for flow over a flat plate, these boundary layers starts developing on all surfaces. And at some point of time, the effect of the viscous forces at the walls penetrates right into the center line. As a result, the boundary layers start interfering, and thereafter it cannot grow any further. Okay. So after that, the flow profile will remain in this parabolic or paraboloid form, and what is the slope of the parabola, etc., will be all determined largely by the diameter. The flow profile, therefore, under what we call the fully developed flow, is determined by the diameter of the pipe. That is the reason why, therefore, the Reynolds number is defined with the diameter as the length scale. Okay? All right. So with that basic assumptions, let us move on to the next course. But before that, I would like you to excuse me for a few minutes. Okay, I'll pause the recording now. It's something that has happened. I need to take care. Just give me 5 minutes. I'll be back.